Our final project was the BevBot, a drink retrieval mobile robot. And here is the team, which consists of myself, Logan, Jay, Sharia, and Noah. So the problem that we are targeting and trying to solve is that getting up and moving around and retrieving things is not always easy for a lot of people, especially those with mobility impairments. So we wanted to make a robot that could be voice controlled and autonomous, that would retrieve the beverage that you would like and bring it to wherever you are. And additionally, we would like to have a trash mode as well, so it could take the empty can from you and bring it to the trash can once you're done.
So our solution is an autonomous drink delivery robot designed to remove the hassle of getting and disposing a drink. The user can request a beverage and the robot will navigate to them and deliver it directly. Once done, they can send a cleanup command and the robot will return, pick up the cup, and dispose of it automatically. The goal here is full convenience, not just delivery, but also handling the cleanup so the user doesn't have to do anything. Now looking at how it works, for that mechanical aspect, we have a cascading lift and a robotic claw. The cascading lift raises the drink up to the user and allows the robot to reach table height to clean up as well. It's driven using a fishing line because of its high tensile strength and low stretch, which makes it reliable under load. Instead of using a return cable, we rely on gravity and weight to bring the lift back down. This still keeps the line tensioned at all times. For the robotic claw, we use a high torque servo motor connected to a gear system to open and close the arms. Rubber bands are applied to increase friction, helping the claw securely grip the drink without slipping. Together, these systems allow the robot to reliably deliver and retrieve the beverage.
Our robot uses computer vision to track cans. It does this by interpreting a picture from the camera as a 3D array. It then converts this into the hue, saturation, and value color space. By doing this, we're able to filter out the color we want, the intensity of that color, and how dark it is. Once the can is detected, we're able to align the robot with the can using the detection. Our robot also uses Monte Carlo localization to combine the encoder readings with the LiDAR. The way this works is data is represented as a particle, and there's a couple hundred of these floating around the map. Each of these produces its own LiDAR values and encoder readings. This is compared with the actual robot, and the ones that are most true to the real world are weighted more in an average. With the combination of Monte Carlo and computer vision, we're able to navigate around our room. The LiDAR detection in combination with the encoders is able to localize us with the Monte Carlo, and this helps us track where we are while we're moving, as well as detecting people around us and stopping if we are too close to something. The camera is also used to detect the cans and move the robots to pick it up. The stop and waiting response is taken care of with the LiDAR, and we know if there's something close to us because we've already mapped the room. And if there's something that the LiDAR picks up that isn't supposed to be there, we can interpret it as a human.
The drink delivery and cup disposal. First, this starts off with a command to be received. The user will speak the drink that is going to be desired, i.e. either a Coke or a Sprite, and it will then be decoded by our voice detection module. This then identifies which drink was requested and sends that data onward. Then it will go into the drink retrieval module, which this module will navigate the robot to the fridge using a pre-mapped room layout, and then it will retrieve the specific drink that was requested, whether you had said Coke or Pepsi. Then once the beverage has been retrieved, the drink will then be going to the user. This is the drink delivery system. This will have the robot going from the fridge to the user, and it will avoid any obstacles that get in the way using a predetermined route that it has calculated from the fridge to the user. If there are any obstacles in the way, it will halt the robot in place so that it will be safe in front of different dynamic options in case that something rolls in the way or a person is trying to walk, it won't hit them. Then we go into the clean command. The clean command is one of the final commands that we can do. When the user says the clean command, the activation word, it will then decode using the same voice module, and it will send a signal to clean the house. It will then clean the room, navigate back to the user, and grab the drink that the user had, and it will then dispose of this into a trash bin of your choosing. And then it is ready for your next request.
The BevBot ended up performing exactly how we wanted it to. It successfully delivered drinks on demand, and it disposed of cups automatically with no user effort required. It responds to voice commands accurately, navigates reliably through the pre-mapped layout that we created, and it adapts to the obstacles in real time. Whenever an obstacle is detected, it stops reliably and efficiently, and then when the obstacle is out of the way and the path is clear, it resumes moving. And this works in numerous environments. And then whenever the voice is detected and the voice recognition, it accurately identifies which drink is being requested by the user. It also recognizes the clean command consistently when it goes to take the can to the trash. It also has a quick response time, so it works very time efficiently and effectively. Some key systems that were used include LiDAR scanning, the HSV camera detection for detecting the different soda cans, and the Monte Carlo localization, a cascading lift, and a voice recognition system, and all of these are working together to complete the task that we set out to do. Some takeaways: the robot proved to be very reliable and adaptable, and it provided a practical solution to successfully complete the drink delivery, to take the drink to the user, and then it also cleaned up autonomously in real world conditions. And here is the contributions and distribution of work between the team members. Thank you.